Although forests occupy only 7% of the Earth's area, they create some of the richest habitats and are considered hotspots of biodiversity on our planet. Forests are home to millions of floral and faunal species. Of some we know nothing about. Lungs of the Earth. Introducing Metza. Jungle. Forest. Why do wildfires occur? Climate change and lightning are amongst the natural causes, but it is man-made actions like ignored campfires, arson, and cigarette butts that result in 90% of the wildfires around the globe. The components that start a wildfire are endlessly present oxygen, readily available combustibles, and natural and man-made ignition sources. A wildfire could spread as fast as 16 to 20 kilometers an hour. To put that into perspective, it engulfs 3 football fields in a matter of minutes. Preventive measures like fire breaks and pulling hoses from nearby water sources are used to control the spread of fires. Current detection methods vary, from simple observation towers to more sophisticated optical and IR-based monitoring solutions. The late detection of forest fires, coupled with inaccuracy and expensive tactics, increase the risk of life, property losses, and overall damage to the ecosystem. A detection system which is effective, accessible, and easy to use is the need of the hour. A team of 9 people decided to take up this troubling challenge. We fireflies set out to tame the wildfires in its most preliminary stage. The underlying problem area identified was the detection of possible fires in remote and vast areas, like forests. The cost, lack of efficiency, and sensitivity in the current methods of detection were other identified pain points. An intense week of design and development kick-started our journey to reach the solution. During this time, the team did a lot of brainstorming, heavy ideation, and even some rapid prototyping, with constant consumption of coffee. The rigorous development and ideation phase of PD6 was our process of elimination. It helped us to understand what might not be an apt solution, and the key components that we would need to build the final system. The system-level concept consists of the following subsystems. 1. A UAV with high payload capacity. 2. A payload that combines supporting hardware with a new highly sensitive fire-detecting sensor. 3. An application with an informative and accessible user interface. Our intense week of work ended perfectly with our Chicken's Got Talent. We began our next phase, connecting Helsinki and Mumbai with remote working. In the year 2019 alone, wildfires have caused unprecedented damage. There were 5,900 fires in Australia, more than 224,000 in the Amazon, and around 1,700 in Europe. These fires have burnt over 393 million hectares of land, which is equivalent to 655 million football fields. In trying to detect and prevent wildfires, there are several stakeholders involved, from hardware manufacturers to policymakers. But those most directly involved are fire officials. Discussions with them helped us understand the depth of the problem at hand. A part of the team visited CERN and learned about new cutting-edge sensing technology. A rigorous process of ideation combined with intensive research brought us to the solution. A highly sensitive monitoring solution mobilized with a UAV. The solution provides the detection of fire at primitive stages, allowing more valuable time for fire officials to plan and act ahead. Fire and its consequences spread exponentially. This system helps to reduce these significantly. Developing a drone that is suitable for our use case was a task of precision. To customize the drone, experts were consulted to help us prepare the final list of components. Our team member, Techas, also participated in a drone building workshop to accelerate the entire process. The drone was first built and assembled successfully in Mumbai, after which it was disassembled to ship it to its final destination, Helsinki. The drone was reassembled, after which we tested its functions and the integration of the custom payload. Development of the payload was a journey of multiple iterations, beginning with identifying and specifying functional and physical constraints. Following these requirements and limitations, the focus moved to computer-aided design. Mechanics and electronics proceeded side by side, and after initial verifications, functional prototypes were built for testing and validation. Fast failures, faster learning, greater success. Our motto while prototyping the payload. We sure did fail. A lot. Followed by even greater success. The interface was designed based on the detection and prevention insights provided by fire officials. The application displays data received from various sensors within the payload and the drone itself. The UI is built for a desktop application, which is easy to use and accessible. The final result of hundreds of hours of development, a high-tech monitoring solution mobilized by an autonomous custom-built hexacopter with a carbon fiber body. This fully customizable drone has a very high payload capacity of 9 kilograms with a battery life of up to 4 hours, and is connected to a ground control station via long-range telemetry. Operation and detection data is monitored through custom application. For detection performance, a custom high-tech payload is integrated into the drone. The payload features an automatic high-speed stabilizing function to keep the sensor focused. Together with the camera, the new cutting-edge UV detection sensor enables fire detection from a range of 800 meters. The rigid structure of the payload is developed to perform in harsh conditions. Upon detection, data is quickly transmitted and then processed, creating an automated fire alert which presents crucial information about the fire. After multiple weeks of manufacturing and testing, the final product was brought to reality as a complete solution. The results are beyond any expectations. The ground control station features our detection software. The drone and payload both feature full performance levels. Active stabilization is precise with quick response. Telemetry provides both sensor data and video transmission from a long range, enabling fire alert. This detection drone is ready for action. We are the Fireflies, and we are detecting forest fires all together.